Okay, today we're going to talk about margin of error. We are going to finally put a name to something that we've been doing for 2 class periods now, and that is when you find a confidence interval, the way to find a confidence interval was to find that mystical number that you had to add and subtract onto both sides. We're going to give that a name today. We're going to talk about it in terms of it being a margin of error. Margin of error is something you see all the time, especially in political contests where they talk about surveys, say that this candidate or this candidate has an advantage and by this percentage, and oh, of course, there's a margin of error. And we're going to see the margin of error is present in a lot of different things, and it's very important to understand what exactly a margin of error can be all about. All right, so let's start with the first one here. Suppose we have a random sample of 50 workers, so we know that N is equal to 50, okay? Mean age, X bar, is 36.4. Standard deviation for the population is 12. We want to find a 95% confidence interval. We worked on these last time in section 8.2, and hopefully what I'm doing is very, very easy. Want a 95% confidence interval. I know then that in this range right here, this has got to be 0.95, okay? I know that alpha is 0.05. That's the area we don't want. So at each end, there's a 0.025. I do a reverse lookup on 0.025, and I get plus or minus 1.96. That is the z-value that you must take times the standard deviation of 12 over root 50. And that'll give you that number that you have to add and subtract on. So to do that, I have 1.96 times 12, answer, and divide by the square root of 50, and I get 3.33. So I know that I have to add 3.33 on and subtract. So adding it on, I get 39.7. Subtracting it off, wait a second, sorry. Adding it on to, I get 39.73. Okay, 3.33. And 36.4 minus 3.33 is 33.07. There is my 95% confidence interval, and I'm assuming all of you can do this. Let's talk about 2 different ways to increase precision, all right? I am 95% confident that my actual population mean is in here, okay? Now, if I wanted to increase precision, I could shrink this in. If I can shrink that in, okay, it's going to more closely push that population mean into a smaller range, and it's going to increase the precision. But if I shrink this in, this percentage gets smaller. So my level of confidence would be smaller. So one way to increase precision, for precision to go up, is to decrease your confidence level. You can't be quite as confident that it's actually going to be in that range because you're shrinking it. And it'd be more likely to pop out of that range, okay? Another way to increase precision is something we've talked about since the beginning of this course. And that is, if you increase the number of people in your survey, you will make a more accurate survey and you will increase precision. We'll talk about that here in a second. All right, let's find a confidence interval for an 80% confidence level. Instead of 95, we're going to do 80. All right, make a couple of changes. This is now 0.80. Alpha is 0.20. This area at this side is going to be 0.10, the area we don't want. Let's do a reverse lookup on 0.10. 0.10 should be negative or positive 1.28. So I have 1.28 times 12 over root 50. Here we go. 1.28 times 12. Answer divided by the square root of 50, and I get 2.17. 2.17 is what I add on to 36.4, and I get 38.57. And I subtract 36.4 minus 2.17, and I get 34.23. Okay? Now, will you notice that we have decreased our confidence level, and we've shrunk this in. You see how they went in from this one? This one is higher, this one is lower. These have shrunk in. This one is now in here, okay, for the 80%. We are less confident, okay, but we've increased the precision. We know the population mean would be in that particular range, okay? All right. To maintain the 95% confidence level, so let's go back. Suppose we want to maintain the 95% confidence level. Now, if you remember, the 95 confidence level had 0.025 at each side, and 0.025 was 1.96. So we know in this particular problem, we want to maintain 95% confidence. So we want to have 1.96, okay? And we want to maintain the 95% confidence level, and this is still 12, but this time it's root n, okay? And I just erased it all, and now I'm gonna have to redo it to remember my numbers. Okay, so this was 1.96 times 12 over root 50, so sorry about that. So I've got 1.96 times 12 divided by the square root of 50. Oh yes, 3.33. The 3.33 is what we're going to add and subtract to get the 95% confidence level. All right, but what if we want to, what do we want to do? We want to increase precision here, okay? So if we want to increase precision, we want to get it down where the range is going to be tighter. Okay, so to get it tighter and increase precision, this can no longer be 3.33. All right, we want to keep 95% confidence, which is this. We want to increase the n. All right, so instead of 50, let's make it, I don't care. Let's make it 500. Okay, we'll keep 95% confidence, but we're going to increase precision. So to do that, let's do it here. We have 1.96 times 12 and divide by the square root of 500. And now I get 1.05. All right, so we're much more narrow than the last time, which was, remember, 3.33. So if you add 3.33 and subtract, you got that range we had before. But look, now you're going to only add 1.05 and subtract 1.05. We have the same amount of confidence, 95% confident. But to get that, to get more precise, we had to go up to 500 people instead of 50. Okay? Suppose we want to get the confidence interval to be 36 to 36.8. We want to maintain 95% confidence level. Well, then maintaining 95% confidence, we still want 1.96 over 12. We're trying to find n, root n, but we want the confidence interval to be that. I mean, really tight on the 36.4. Really tight on 36.4. What are we adding and what are we subtracting here? Isn't it 0.4? We're adding and subtracting to get that. So what we're going to add and subtract is 0.4. Okay, super, super tight. Can we solve this for n? I'm going to multiply root n over to this side. And 1.96 times 12 is 23.52. And now, can we solve that? Divide by 0.4 and get root n is 58.8, okay? And to solve, get rid of a root, you've got to square that guy. And I get 3, 4, 5, 7. Yeah. You can maintain 95% confidence. You can maintain it. You can get it down to that precise, super precise, but look how many people you're going to have to survey, okay? Supposing budgetary restraints do not permit surveying more than 2,500 people, okay? Let's see if we can only survey 2,500 people. We can only survey 2,500 people. 12 still stays put. What happens to my confidence level? What happens to my confidence level here? Okay, the Z value. What happens to that if we want to maintain this amount of precision and we want to maintain, and we can't use more than 2,500 people? Okay, so we need to solve this for Z. All right, so let's do it. 12 divided by the square root of 2,500. I think the square root of 2,500 is 50, right? So it's 12 divided by, and I get, try that again. And I get 0.24, okay? So 0.4 equals Z times 0.24. So divide by 0.24. I get 1.67 for a Z value. Now, if Z is going to be 1.67 on the right and negative 1.67 on the left, what is my confidence level? So you see what I've got, folks? I've got a 1.67 negative here and a 1.67 there. So let's find the area below. So look up negative 1.67 is 0.0475. 0.0475. So what is my confidence level? I have double 0.0475 times 2 and take it off of 100 or 1%, 100% or just the number 1, and I get 90.5% confidence, okay? Now, to give this thing, right here, when you take the Z times the standard deviation, to give that a name finally, we're going to get to calling it the margin of error. All right, so here we go. Suppose X bar is 38.8, sigma is 12.1, find n so that we can be 95% confident that the interval for mu will be plus or minus a half. All right, so what we've got here, we have X bar is 38.8, okay, sigma is 12.1, okay, find n, we want to be 95% confident. 95 is 0.95, this is 0.025, and I've looked this up so many times, why can't I remember it? It's 1.96 and negative. So I have 1.96, okay, times 12.1. We want to find n, so that we can be 95% confident that the interval for mu will be plus or minus a half. Plus or minus a half, that 1/2 is defined to be the margin of error. Okay, so can we solve this? We did many of these, so we just did some a couple of minutes ago, so let's do it again. Multiply both sides by root n, so 0.5 root n is 1.96 times 12.1, and I get 23.716, divide by 0.5, and square it, and I get 0.2250. There has to be that many people surveyed to be able to be 95% confident and to get a margin of error of 1/2. When you take the z-value times the standard deviation, you get the margin of error, okay? Keep the confidence level 95%. So I have to keep this. X bar is still 38.8. Find n so that the margin of error is 1, okay? Find n so that the margin of error is 1. So let's fix it up. If the margin of error is 1, multiply by root n, I have root n is equal to 1.96 times 12.1, and I get the 23.716 that I have, square both sides, and I get n 562, okay? So, what is the actual confidence interval? If the margin of error is 1, would it not be 37.8 to 39.8? You add 1 and subtract 1. What is the length of the confidence interval? If you add 1 and subtract 1, isn't that a length of 2? Suppose the length of a confidence interval is 5, x bar is 20.2. Can you find the margin of error? Heck yeah. If the total length is 5, aren't you adding 2.5 and subtracting 2.5? Can you find a margin of error? Sure, it's 2.5. Suppose the confidence interval is 54 to 60. Can you find the margin of error? Yes. 54 to 60, you could find the middle is going to be, when you average those two, you get 57, I think. 54 plus 60 is divided by 2 is 57. Yeah. What's the margin of error? 57 to 60, 57 to 54, isn't it 3? Or you could take the total distance between the two is 6, cut it in half is 3. The mean of the sample was 57. Okay, interesting video here where they're talking about margin of error when it comes into play in DUI, driving while intoxicated, in DUI breath test. Okay, this is very, very interesting.
Now, putting aside all of this, there's also an inherent range of error with the breathalyzers. Now, there's some disagreement among experts whether the range of error is a 0.01 or 0.02, but I think the sort of consensus in the community is that it's a 0.02. And it's important to understand what that means. That's saying that even if none of the problems that I just discussed exist, even if everything was done perfectly, there's still always going to be an inherent margin of error of 0.02. So somebody who blows a 0.09 really could be a 0.11, or they could be a 0.07. Now, because of this, nobody who blows a 0.09 or 0.08 should ever be charged with DUI, because it's unfair. They should be given the benefit of the doubt. They're within the margin of error. And any scientist would tell you, you could never draw a scientific conclusion based on a data point that's in the margin of error. We have a saying in our criminal justice system that it's better to let 10 guilty people go free than to convict one innocent person. And yet every day we are convicting people of DUI, taking away their license, taking away their livelihood, sending them to jail sometimes based on spurious evidence. If you took a DUI breath test and the reading from the machine simply does not match the drinking pattern, simply does not make sense given the amount of alcohol that you actually drank, then we encourage you to fight back. Call us here at Shouse Law Group, tell us the circumstances, we'll evaluate the case, and we'll see what can be done to keep your charges reduced or dismissed.
Rather interesting. Now, granted, the maker of this video, I understand what, they're trying to get clients and get people that were stopped for DUI. to go to their law office. I agree, I understand what they're doing, but it is interesting to note what he said about the margin of error. If you're within that margin of error, you should not be cited for driving under the influence. And it's a really interesting aspect, practical application of margin of error. All right, a couple of final problems here. The first one is we can work it out. So the first one, sample randomly selected millionaires. We already talked about those. X bar is 58.53. Standard deviation is 13.36. We want a confidence level of 95%. So we know this is 0.95, this is 0.025, and I think it's 1.96, 0.025, yep, plus or minus 1.96. So I have 1.96 times the standard deviation of 13.36 over square root of 300. Okay? So let's find the margin of error by multiplying this out. So I have 1.96 times 13.36 equals divided by the square root of 300, and that is 1.51. Okay? Margin of error of 1.51. And what is the confidence interval? I've got to take 1.51 and add it and subtract it to that. Okay? What does the margin of error mean in the context of this problem? Let's just add this and subtract it to make sure we can talk about this. So 58.53 plus 1.51 is 60.04, and 58.53 minus 1.51 is 57.02. Let me double check that. 1.96 times 13.36 divided by the square root of 300. Yeah, 1.51. So we've added and subtracted. There's the confidence interval. What does the margin of error mean in the context of this problem? We are 95% confident that the actual mean age for millionaires in the United States is going to be within this range. And if we use this range, okay, we are 95% confident that the biggest error we could make is 1.51. Okay, suppose that a confidence interval has length of 20 with a sample mean of 52.4. Can you find a confidence interval if its total length from start to finish is 20? 52.4 is dead in the middle. So don't we have to add 10 and subtract 10? 42.4 to 62.4, adding 10 and subtracting. Can you find a confidence level? No. We don't know the percentage. We don't know how many people were in the survey. We can't find it, but we can find the confidence interval. Okay, margin of error. As I mentioned, it is talked about frequently when you're dealing with political situations and they tell you a margin of error. One very personal thing with me is the margin of error versus VASCAR, okay? VASCAR, just to explain what's going on here, local policemen in Pennsylvania are not allowed to use radar to catch speeders. So what they have done, they use something called VASCAR. It is like a calculator on steroids. A cop will sit alongside a road where he has drawn white lines across the road perpendicular to the sides. Drive through Selinsgrove, you'll see these on many of the side streets. If you see white lines going across the road, you know that a policeman could be sitting there with his VASCAR machine, okay? And what he does is he hits a button when your car hits the first line, and he hits a button when your car hits the second line. The machine knows the distance figures out the time between the two buttons being pushed and gives that officer a speed, okay? And then you can be pulled over for speeding. But if you do the math, and if you even give him a reaction time, normal reaction time of 0.25 seconds, okay? In a 55-mile-an-hour zone, the margin of error is so big. Look at that interval. Look at that interval. He could say, just from his reaction time alone, pushing the button, that you were traveling 75.20, and he's trying to do the best job he can. He just screws up with his finger pushing the button, okay? Margin of error is much, much, much too big, okay? Why do I know? Because I got a ticket. And I requested a day in court, and I went before a judge and showed him the mathematics of all of this, okay? I even gave him a handout, okay? Gave him a handout and showed him, and I could tell that he knew what he was doing was not right, okay? And the policemen in that particular county were pulling people over, and it was a gold mine for the county. They were making all kinds of money on tickets. Look at that margin of error, okay? No one should ever be pulled over and told they're going a speed in this range because the margin of error is just too large. Okay, answer true or false to each statement. Length of a confidence interval can be found if you know only the margin of error. Sure. What you add and subtract, you just double that. That would be the total length. Margin of error can be determined if you know the length. Sure. Cut it in half. It's what you add and subtract. The confidence level can be obtained if you know only the margin of error. No, you don't know the percentage. You don't know z-values. You don't know how many people were in the survey. Okay? The confidence interval can be obtained if you know only the margin of error and the sample mean. Sure, you add the error on and you subtract it off. All right, homework. I've got 3 extra problems right there that are kind of interesting and some book problems down at the bottom on section 8.3.